Welcome to the MTD Technical Corner. Today we're going to be looking at fifth axis solutions from SolidCAM, and I'm joined by Ben. Ben, welcome to the MTD Technical Corner.
Thank you.
Ben, great subject, and I'm looking forward to get into this and dive into this technically. But what has driven the evolution of CAM for fifth axis machining solutions?
So if we start from the beginning with 5-axis, you've got 3+2, 4+1, right up into simultaneous 5-axis. So the key driving point really is the complexity of parts being designed in CAD systems, so like SolidWorks and Inventor. The more complex the part becomes, the more need there is for a 5-axis machine. So even in 3+2, you're cutting down setups. So from 3-axis machine onto a 5-axis machine, you can do it in 2 ops rather than maybe 5, 6 operations. Right then up into simultaneous 5-axis, where the complexity of the part demands the more complicated tool paths, as you can see here with the barrel cutting.
I mean, with an application like this, Ben, it's safe to say it would be pretty much impossible to program this by hand.
Yeah, especially in the timescales as well that we can program it. So you may be able to create the tool path manually, but yeah, far easier using CAM software, driving directly off the model from the CAD system.
So simplification of programming parts such as this, how is this achieved from SolidCAM?
So SolidCAM has a nice, easy to use interface. Right up to the complexity of 5-axis. So if you're already a SolidCAM user, for instance, you already know how to do the 2.5D profiling, things like that. Up into 5-axis simultaneous, it's the same window, same graphical interface, exactly the same usage inside SolidCAM. So it's then just a matter of deciding what surfaces you're going to use, what tooling to use, and you can generate the tool paths pretty easily. With
the SolidCAM package, as you're saying, you're kind of growing into a package such as this from 3-axis machining. Is this quite common?
Yeah, so you've got customers where they've already got SolidCAM, they've already got 3-axis machines or simplified machines. They may then venture into getting a more complicated machine, and we can just grow with that customer, adding on the necessary modules that they need.
Now, we're looking at this application again, and this looks like barrel cutting to me.
Yeah.
What advantages do you get from programming a part like this with a barrel cutting tool?
Well, the initial advantage and the most common advantage really is the step down and the time saving over using a ball nose tool. You can see here on this cutter, using a 2mm step down on the semi-finish and then a 1mm step down on the finishing cut gives us a nice surface finish. As opposed to on the ball nose, you're probably looking at 0.1 step over on there. So already you're at 90% cycle time savings just from the step downs.
90%?
Yeah, and then the other advantage then of a barrel cutter is keeping the tool nice and short. So we can, it's not just for curved faces. You can see on this component here, we actually barrel cut the lower face on here because the access using a straight tool is not, you just can't get in there, so use the barrel cutter to create that flat face as well as creating this sort of nice shape.
So this is really important feature there, because then you're not getting the vibration that you would have done if you're using a longer tool.
Correct.
Is that correct?
Yeah, so if we was using this on here, we'd be at 90 degrees, the table would be in the way as the head's coming down, you'd have a nice long tool stuck out trying to machine across here, whereas we have the barrel tool, which means we can tip up like this and have the contact point on there and still produce a nice surface finish.
So we're touching on barrel tools, but there's lots of different tools such as lens tools that you can use. Can you explain in a little bit more detail of the kind of applications you'd use with these tools and what that tool means?
Yeah, so a lens tool is part of the barrel family, but the actual convex of the tool is on the bottom of the tool. So whereas you would have a ball nose, say for instance you'd have a 12 diameter shank, 12 diameter ball nose, yeah, you may have a step over of 0.1 to create a finish on there. With the same size tool, so 12mm, you can have a lens tool on the bottom, so maybe 25 diameter, 25 radius, sorry, on the bottom, which is effectively a 50 diameter ball nose. So you can then use that for 3-axis work. So you could generate this shape here in 3-axis. So barrel cutters are not all about 5-axis. You can use them in 3-axis machines as well.
Like you mentioned, 3+2, 4+1, or full simultaneous, and some of these demos that we can see on the screen here kind of highlight that you can actually machine any complex component using your CAM packages.
Yeah, that's correct, yeah.
Now, one thing that is really important with the complexity of the components, but not only the components, the complexity and the evolution of the technology and the machine tools, how easy is it to interface your product with a machine tool?
So that's where the post-processors would come in. So we write and develop all the post-processors in the UK locally. So they're all done by us at our technology centre in Barnsley. We would go out on site, test the post-processors, make sure everything's working correctly so that when the code comes out of SolidCAM, it's in the machine and it's ready to run. There should be no manual edits between CAM and the machine.
So you're reducing any potential downtime.
Correct.
Simplifying the programming.
Yes.
And making it easy, I suppose, for people working within the organisation.
Yeah, that's correct. You sort of you're creating that standard as well. So you've not got two people programming in a different style. We create the same code for different machines on the same machine, different jobs, and everybody can read that code, use that code.
So employees, programmers within an organisation, you're standardising the programming within that organisation, and what kind of benefits would you get from that?
So the benefits from that is obviously everybody can move around machines, everybody can look at that code on different machines, see it in the same style, the same layout. You've also got different jobs obviously being done with the same tool paths, the same strategies as well.
So Ben, there doesn't seem to be any limits with your solutions and CAM solutions that you offer, but the product is one thing, but what about the technical support that you can offer?
So that extends on from the post-processors being locally supported. Technical support again is all local, it's all run from the technology centre. We've got the engineers there ready to assist with any programming, any issues that they may have with using the software, straight into an engineer, get the response they need straight away, carry on running the machines.
So you practice what you preach?
Correct, yeah. We've got the technology centre where we've got machines in the technology centre to prove the capabilities and what we can do. We have open days and open houses there. Anybody's welcome to come and have a look at the technology centre at any time. We'll show them the functionality, we'll show them exactly what we can do.
So for any existing Fifth Axis users or any new Fifth Axis users that have watched this Technical Corner, how should they get in touch and how can you help them?
So they could just get in touch with us, contact us by phone, email, however they prefer. We can come and do an on-site demonstration, we can come to your facility, we can prove our capabilities on your machine, on your parts.